Hello Math 3, welcome to your first flipped classroom video. So we of course are going to start with Module 1, Section 1, 1.1. So make sure that you have at least a notebook ready, and it would be really great if you could have some graph paper. You're definitely going to need graph paper moving forward, so if you don't have it yet, I would really start bugging your parents to drive you to Staples or Walmart to go pick some up. All right, so to get started, the name of the task is Brutus Bites Back. So it says, remember Carlos and Carlita. A couple of years ago, they started earning money by taking care of pets while their owners are away. Due to their amazing mathematical analysis and their loving care of the cats and dogs that they take care of, Carlos and Carlita have made their business very successful. To keep the hungry dogs fed, they must regularly buy Brutus Bites, the favorite food of all the dogs. Carlos and Carlita have been searching for a new dog food supplier and have identified two possibilities. The Canine Catering Company located in their town sells 7 pounds of food for $5. Carlos thought about how much they would pay for a given amount of food and drew this graph. Write the equation of the function of the function that Carlos graphed. So this should be hopefully somewhat of a review. All they're asking for you to do here is write out a linear function. So to kind of jog your memory, a linear function is always in the form y equals mx plus b, or you might see it sometimes as f of x equals mx plus b. The second one is called function notation, and you're definitely going to want to be familiar with that as we will be using it during this lesson. So it says write the equation of the function that he graphed. So to reiterate, in this y-intercept form, we know that m is the slope and that b is our y-intercept. All right. So first thing we need to do is find the slope. So when you're trying to find the slope of something, it's really good to get a solid point that's right kind of where two lines meet up. So looking at this graph, I see that right here would be a really good point to use. All right. So we could use that point and this point to find the slope. So there's many different ways you could do, change in y. Wow, that's huge. Change in y over your change in x. You could do that. I'm just going to show you how to do it using the slope formula. And I'm going to show you that because really you can apply that to any situation. So the slope formula is y2 minus y1 over x2 minus x1. This should also hopefully be pretty familiar to you. And we do have 2 points here. We're going to use our 0, 0 point. And then we're going to use our 7, 5 point. So then all we do is plug this into our formula. I'm going to make this my y2, x2, my x1, y1. So I'm going to go ahead and plug those in. I get 5 minus 0 over 7, 7 minus 0, which gives me 5 over 7. And that tells me that that is going to be the slope of my line. Now, I need to find my y-intercept. Your y-intercept is where the line hits, wow, I need to make that smaller, hits the y-axis. So clearly it hits the y-axis at 0, all right? So your b is going to equal 0. So now all you need to do is plug that in. You're going to say f of x equals your slope, which is 5/7, x plus 0, and typically we don't write the 0, so your actual answer, sorry, I'm running out of space here, I'll write it below, would just be f of x equals 5/7 x. So that would be your answer for number 1. Next, we have Carlita. So Carlita thought about how much food they could buy for a given amount of money. So let's kind of think about this real quick. So if we look at Carlos's graph, he thought about how many pounds, let's see, he wanted to know how much they would pay for a given amount of food, right? So he looked at pounds first and then the cost. Then if we look at Carlita's graph, she thought about the cost, then the pounds, all right? So her graph looks a little bit different. And they want us to come up with the equation of Carlita's graph. So of course, we're going to use our y equals mx plus b. And let's again find 2 good points. So we're going to use 0, 0. And then I think 5 comma 7 is going to be good. So we're going to use 0, 0, 5 comma 7, and we're going to go ahead and find our slope, which is y2 minus y1 all over x2 minus x1. So we can plug those in. I get 7 minus 0 all over 5 minus 0, which is going to give me 7/5. So that gives us our slope. Now we need our y-intercept. So our y-intercept is, again, where the line hits the y-axis. And in this case, this also happens at 0. So our b is 0. So now all we got to do is plug it in. We're going to say f of x equals our slope, which is 7/5 x, plus 0. And of course, we don't like to write that 0, so we just have f of x equals 7/5 x. All right. So that is how you would want to write that equation. Now, number 3 says, write a question that would most easily be answered by Carlos's graph, and write a question that would most easily, that would be most easily answered by Carlita's graph. What is the difference between the two questions? So if we look at Carlos's graph, okay, his input, right? If I want you to think about a function, right? When we have a function, it's always input, output, usually x comma y. In this case, his input is pounds. That's where it's on the x-axis there. And his output is dollars. So the question Carlos's graph is going to answer is how much does, you could say, p pounds of food cost? All right? You could think about it this way, right? How much can you get? How much does 5 pounds of food cost? That's what his graph would answer. Okay? So we could put that down. Carlos. How much does 5 pounds of food cost? All right. And really that 5 could be replaced by anything. You could say how much does X pounds of food cost, right? Because that's on the x-axis. So you could say how much does X pounds of food cost? Now let's go ahead and answer Carlita's graph. All right. If we look at Carlita's graph, her input is dollars and her output is pounds. All right. So her graph answers how much food can I get for X dollars? Oops. So, next, it says, what is the relationship between the two functions and how do you know? So what I want to kind of do is let's look at the input and the output. So for Carlos's graph, our input is pounds and our output is dollars. For Carlita's graph, our input is dollars and our output is pounds. Okay? So let's go ahead and write that down. So for Carlos, I'm just going to put a C. We had our input was pounds. Output was dollars. Oh, they're both C. Haha. We'll just have to write his name then, I guess. We have Carlos and then Carlita. Her input was dollars. Output was pound. So they're kind of flipped, right? So you could say between the two functions, they flipped the input and output. All right. So one thing I want to point out is there is a special name for this. When you have a function and you flip the x and y values, that's actually called an inverse. So you could say that these functions are inverses of each other. All right, they're a very similar function. They're just flipped, the x and the y values. And in this case, it's the pounds and dollars. All right. So next, for number 5, they ask us to write this in function notation. All right. So let's kind of think about this. I kind of wrote this a little bit in function notation here. All right. But let's go ahead. Think about it this way. For Carlos, he had pounds on the x-axis and dollars on the y-axis. All right. And normally, we have x, y, and we would say f of x equals y. Okay. So to write Carlos's function in function notation, we're going to say f of p equals d. All I did was rearrange the letters on here. Our input was p, our output was d. So then for Carlita, her input was dollars, her output was pounds. So her function would be f of d equals p. All right, so now I want you guys to go ahead. Those of you who printed out the packet, you're going to have to flip to a page. The rest of you, you can just write this down on a piece of paper. I wanted to do some example problems with you from the Ready, Set, Go. It's from the Go portion of the packet. And I just kind of wanted to do a couple of these with you so that you get a little bit of practice and it's not as daunting tomorrow when you are doing them in class. So what we're doing here is we are doing function notation. All right. So I'm going to go ahead and do the ones in this row. So if you look at number 18, it's asking for g of 10. So what we need to do is we need to plug in 10 for x. So g of 10, well, here, how about this? We know g of x equals 5x minus 12. So g of 10 is going to equal 5 times 10 minus 12, which is going to give us 50 minus 12, which gives us 38. So that's how you do number 18. Then for number 19, we have g of negative 2. So again, we need to plug in. I'm going to zoom in so it's a little easier for me to write. We need to plug into g of x. To reiterate, g of x is 5x minus 12. And we're trying to do g of negative 2. So that's what we're going to plug in. So we get g of negative 2 equals negative 10 minus 12. G of negative 2 is going to give us negative 22. So far, they shouldn't be too bad. Really, all you're doing is plugging into the function. Now, the next one seems trickier, but it's really not that bad. They want us to find g of a. So again, we know that g of x equals 5x minus 12. So if we're trying to find g of a, all we're going to do is plug in a for x. So we get 5 times a minus 12. Now, in some cases, you might have to simplify, you might have to distribute, you might have to FOIL. But in this case, you're done. You can't simplify that anymore. So that one was super duper easy. So now for number 20. We know that g of x is 5x minus 12. And what we need to do is we need to plug in a plus b. So we're going to have 5 times a plus b minus 12. Now this one's a little bit trickier. Here, we're going to have to distribute. All right? So we're going to end up with g of a plus b equals 5a plus 5b minus 12. In this case, there's no like terms that you can combine, so you are again done.